DNA.
Initially, Kenyon believed that proteins could have formed directly from amino acids without any DNA assembly instructions. And that's why so many scientists were excited about his theory. But the more he and others learned about the properties of amino acids and proteins, the more he began to doubt that proteins could self-assemble without DNA.
In DNA, Kenyon encountered a molecule with a property he could not explain through natural processes. For locked securely within its double helix structure is a wealth of information in the form of precisely sequenced chemicals that scientists represent with the letters A, C, T, and G. In a written language, information is communicated by a precise arrangement of letters. In the same way, the instructions necessary to assemble amino acids into proteins are conveyed by the sequences of chemicals arranged along the spine of the DNA. This chemical code has been called the language of life, and it is the most densely packed and elaborately detailed assembly of information in the known universe.
Like other scientists working on the origin of life, Kenyon realized he had two choices. Either he had to explain where these genetic assembly instructions came from, or he had to explain how proteins could have arisen directly from amino acids without DNA in the primordial oceans. And in the end, he realized he could do neither.
It's an enormous problem how you could get together in one tiny submicroscopic volume of the primitive ocean all of the hundreds of different molecular components you would need in order for a self-replicating cycle to be established. And so my doubts about whether amino acids could order themselves into meaningful biological sequences on their own without pre-existing genetic material being present just reached, I guess for me, the intellectual